from the Fajardo River. And for us, an increase in stream flow there means increased penetration of very turbid water just because of the watershed conditions. And it comes from the Yunque rainforest. Once it gets out of the forest, across the urban area of Fajardo, and that's where the problems start. And when you look at this, and this is a clear inverse relationship between the river inputs and the coral skeletal growth, but it also, we have data also that I'm not going to address much of that, but in terms of connectivity, most of these reefs that according to very old fisher folks there, those reefs were really, really highly productive until the late 50s, early 60s. Once they built the sewage treatment facilities, they expanded the urban areas and the urban horizontal sprawling. That's when the problems, according to the fishermen, started, just because of the runoff going to the river, etc. So it's interesting because the fishermen tell a story that can be corroborated by science. This is data from the southwestern coast of Puerto Rico, another manuscript that we are hoping to send before the end of the year. This is the Cabo Rojo area, and you can see the scale here. This is about 8 kilometers long. This is across the shelf from the Cabo Rojo area to the shelf edge. We were looking at certain 11 different coral reefs along the region. We measured several parameters. This is one of them only. This is ammonia. And these are areas that have several illegal sewage connections right to the Boquerón Bay. And you can clearly see the magnitude of the circle can tell you an idea of what is the situation in terms of very, very high ammonium levels on those areas. And the farther you move from the shore, the water quality conditions increase. And this is an example of coral species richness. And the colors are the inshore reefs, the mid-shelf reefs, and those adjacent to the shelf edge. And you can see an increase, a general trend of increasing coral species richness with distance. And when you look at the ammonia concentration across those reefs, you can actually see that there's a difference, a gradient of conditions, that those areas that had the higher ammonium concentrations had the lowest coral species richness. So there's a decline in diversity just because of those conditions. And when you look at coral recruitment and the coral recruit assemblages across the same land-based pollution gradient, this is recruit density as a function of turbidity. The lower the turbidity, the lower, the higher the transparency, was the highest density. But once the turbidity started increasing, you had a very rapid decline in the density of coral recruits. And this is the same. This is density, and you can see diversity also here. This is for inshore, mid-shelf, and close to shelf edge sites. So the structure of the coral spat community is showing that trend. When you look at fish assemblages, you can also look at, this is a fish species richness also for within inshore, mid-shelf, and shelf edge sites. And the structure of the community, you can see that this is the curve of cumulative dominance in fish. The closer you get to the shore and to the high pollution areas, you have a shift in the community. Some fish taxa that simply cannot exist on areas that have been significantly degraded. I mean, I'm talking about now a chronic condition, This other data set is from Culebra. We did the same in an island which has only 2,000 residents. It's only 7 miles by 4 miles long, etc. We assess it through a distance gradient across different reefs using the same approach, inshore, mid-shelf, outer shelf. And this is mean coral cover as a function of horizontal water transparency. This is a no-brainer. There's a linear increase in percent coral cover, and you can see it here in the graph. The differences is 3 different depth zones. And it's interesting because you can see on those offshore pristine reefs that has very high visibility, but there's a major gradient in coral cover, and that's because an invasion of Ramicrusta textilis, which is a red encrusting algae, which is literally engulfing staghorn coral thickets. We have amazing populations of staghorn corals that are being overgrown by this algae. We just got an approved grant to start doing some coral demographic analysis with the interactions of the algae, so we'll be addressing that aspect later. And this is mean coral cover as a function of chlorophyll concentration. Culebra doesn't have rivers, but they don't have a really functional sewage treatment facility. So most of the sewage is still being pumped out to the bay. And with the ebbing tides, all of that water is moving through part of those reefs. So you can actually see greenish water in those areas, and you can see higher chlorophyll concentrations, and the reef, there's a decline in the percent coral cover. This is recruit density. It follows the same pattern that I mentioned, lower recruitment in areas that are degraded, higher recruitment in areas that are farther away. This is the same data. This is for the western coast again. This is species richness for coral, and this is percent coral cover. It increases with distance, and there's an increase in turbidity closer to the shore, and also in phosphate concentrations closer to the shore. So again, these are showing that water quality conditions create a problem, and this is coral recruitment across the same distance gradient, moving from inshore to the shelf edge. And you can actually see a relationship between with declining coral recruitment, with an increase in turbidity, and also with ammonium concentration. And you can see here coral recruit density is the same. I'm sorry, no. And that's as a function of dissolved oxygen concentrations. So once you move out to the shelf edge, your water conditions increase and increase in oxygen levels, then you have an increase in those corals. So when you look at the spatial pattern in the structure of coral communities, you can see that those areas that are being affected by stormwaters, or a combination of stormwater and some raw sewage, you see that particularly those areas closer to the shore are basically dominated by habitats that change a little bit in salinity, changes in salinity pulses. You have areas that are literally impacted by sewage, and you have that this community structure is mostly explained by changes in optical brighteners concentrations in ammonium, chlorophyll-o, etc. And those outer shelf reefs are dominated and better explained by this higher dissolved oxygen concentrations. We also did before, and that's a paper that was published in Marine Pollution Bulletin some time ago in 2009, using PCR-based methods to address sewage impacts across the shelf. It turned out that waters that were in compliance with legal standards of enterococci or fecal coliforms were actually not in compliance, because when we look at DNA of different indicator microbes, we found out that there's a large component of microbes from human fecal pollution, but also from cattle, from horses, and from other animals. But those were closer to the shore. Those from human sources were even off-shelf, and the shelf edge there is close to 15 miles from the shoreline. So you could see also a gradient of habitats, and those coral reefs that were thought to be kind of pristine or in better shape were actually impacted by recurrent pulses of sewage. And when we look at the structure of the reef community, there was a difference, and again, the same pattern, a gradient in conditions. Those offshore reefs had higher coral cover, and especially Acropora palmata, which is the dark part of those bars, was higher in offshore reefs than those from the inshore. So you can actually see, again, the same splitting between inshore and offshore sites. So, what is this? What has happened then also, as I mentioned before, once you have change in the community, you have the macroalgae taking over the reef, and when we look at the coral reef, of the coral recruit density as a function of macroalgal cover, you see a rapid decline and a change. This is in particular from Mona Island. We wanted to know what was going on in Mona after the 2005 massive bleaching event that resulted in the major coral mortality episode, and we started addressing the recruit patterns in Mona. And it turned out, interestingly, the habitat that was dominated by Orbicellas, the dead Orbicellas after the mass mortality, were now being overgrown either by macroalgae or the recruitment composition of the benthic community composition of those recruits were actually dominated by other things. Okay, we're talking about reefs that were, in one hand, a change in benthic community structure by ephemeral, high disturbance-adapted species, small-sized corals like Siderastes radians and Poraires astrioides, etc. And this indicates a major shift a major recent shift in the trajectory from those high, very large, massive reef-building species, and now reefs are being dominated by basically non-reef builder taxa. So that tells you that tells us that there's a major change in the benthic community composition going on, and those former habitats dominated by those reef builders are now dominated by something that is not a meaningful reef building species. What we think is going on in the case of Mona? Well, a combination of things. Definitely there was a massive bleaching event, and we had another one in 2010 that it wasn't worse just because we had a hurricane. Hurricane Earl, when Hurricane Earl passed through the northeast of Puerto Rico, we had a decline of 3 degrees centigrade in the temperature, and that stopped the bleaching right at the beginning. Okay, so bleaching across the eastern shelf was never exceeded probably 30% or more. In Mona, it went to about 50%. But that was about it. Temperature was even higher than in 2005, but we were lucky. Hurricanes saved the reefs there at that moment. We also have had a high prevalence of yellow band disease in the case of star corals, a major increase in non-palatable macroalgal overgrowth, and it creates a problem of interference competition for the coral spat. We have a problem of serial overfishing. We have Puerto Ricans, and we also have sometimes Dominicans coming to the Mona Island. It's so far that it's very difficult to, and sometimes you see the Coast Guard hanging around, etc., but sometimes they just come and fish and disappear, you know, and we have even airplanes patrolling, but they do it because I've seen them coming to fish. Even the service providers for tourists, they come and fish in the no-take area, and no one says nothing about it, but that's, okay, I said that over the internet. Time for a beer. This is stuff that is very well documented. We still have a lack of recovery of Diadema antillarum, as I mentioned earlier in the past. The Mona Island reefs, they are so far that there's a limited connectivity with other reef systems. And that takes us to the aspect of herbivory. Herbivory is a very important component. And if we fail, I'm talking about the governance component, to address these issues, for instance, if we don't pay any attention into managing either the fisheries because of the serial overfish effect, you get rid of the top predators, then the next predator, then the next one, and then start fishing the parrot fishes, etc. And like in Jamaica, when I saw them, they were fishing also the acanthurids, and now they are eating the dancerfish. I got a dancerfish soup, fish tea. I mean, it's serious. I mean, overfishing. I thought that Puerto Rico was overfished until I saw the Dominican Republic reefs and those in Jamaica. So if there's a poor management of fisheries and diadema, then you have a decline in herbivory, okay? In herbivorism. Then if you have a poor management of the components of our competition and facilitation, then you have to deal with the macroalgal overgrowth and losing your crustose coralline algae. So if you lose the CCA, you lose the habitat necessary for the coral recruits, for the coral larvae to actually settle on the reef. If you have poor management of the reef building activity, in the long term you will end up with the declining in the density of reef builders, in overall recruitment and overall coral diversity. And if we have poor management of ecosystem resilience and connectivity in the long term, we will end up by losing the accretion rates and the ecological and mesoscale connectivity, which is important for keeping the systems functioning. So how can I convince a manager or a decision maker at a government agency about aspects that we need to address? It's difficult because probably most of that people doesn't understand that kind of language, and it's a challenge for us as scientists to convert this into meaningful information. Apologies because I did not bring, so I forgot last night to place I fall asleep. I ended up this like at 3 a.m. It's Maria's fault and Natasha's. No, just a joke. We still have in Puerto Rico a particular issue of areas that were bombarded by the U.S. Navy and other nations during many decades. And some of the reefs in the eastern coast, especially in the islands of Vieques and Culebra, if you would like to get more information about it, we did publish already this in Revista de Biología Tropical. But I'm going to bring some of examples of why this is a threat to persistence and resilience, at least on those local scales. In the case of this study that was focused in bombarded areas, within craters in the reef, in comparison to adjacent areas, the red color are the bombarded grounds, and those are like controls, kind of close physically, not too far, less than a kilometer away, in areas that were not directly hit by bombs. And there's a striking difference in percent coral cover among these sites. But when you look at coral recruit patterns, and these are examples of two of the sites that we look at for coral recruitment, and those are control sites. This is the species richness of recruits. This is the recruits density in craters and outside, the diversity of recruits inside and outside the bombarded areas, and in evenness, there's a very high variation there. But craters are not naturally recovering just because there's not much recruitment. Probably there is, but as the substrate is so unstable just because it got demolished, if you have a coral colony, coral recruit establishing in an area that is overturned by the next major wave action, then it dies. So in the long run, the effect is like having no recruitment. Probably there are larvae establishing, but they're not successful just because of the instability of that bottom. In terms of the functions of these disturbed habitats, this is fish abundance. And when you look at control areas in comparison to bombarded areas, there's a major difference in the composition of species. In this case, it's abundance. And when you look at the biomass of the fish, also you see a striking difference. You don't have any three-dimensional structure, so that affects the function of producing habitat for fish, so that changes the whole story there as well. Now, that's enough about for local scale things. When we get to regional scale phenomena, we got, and this kind of information that was produced by Scott Heron from NOAA, which is one of the collaborators of Frank's group. And this is a reconstruction of chlorophyll pulses for the eastern part of Puerto Rico. And you can see there are some areas that you can see some interesting pulse events. Those gray, like shadow peaks were major chlorophyll pulses associated to either, and you can see this is a map of the Caribbean and animation, and you can see this is the Orinoco River from Venezuela. And actually this plume comes from the Amazon River in Brazil. So those two kind of tiny rivers sometimes move around and can impact the entire Eastern Caribbean region, and you can see the eddies moving around here. It's not like it's going to be fresh water. Probably the change might be 1 part per 1,000, but that brings enough nutrients to the areas to increase the chlorophyll level several, well, let's say like from a mean value of 1 microgram per liter, probably to about 5. And that's like a lot. And the water becomes green and the fishermen get crazy because of the water start getting greener. And when it happens in combination with temperatures about 29 degrees, you have a very rapid mortality episode in acroporic corals. In addition to that, every time there's a negative North Atlantic Oscillation Index, the conditions really change in the Atlantic region, especially in the tropical Western Atlantic, because if you have a negative now, what happens is that you got a decline in the trade winds, you got an increase in the sea surface temperature just because you got doldrum conditions. So it's like October and September normally for us are like the normal doldrums, but you can have these conditions like what we had in 2005 right from April, which normally is really windy for us. So we had like 6 or 7 months of doldrum conditions all over, and that's when things got tough for the reef. Normally you can have a decline in atmospheric pressure, so you can have an increase in the frequency or probably severity of hurricanes. You can have moderate to massive bleaching, and we also had extreme rainfall and runoff, for at least for our area, because of the conditions were good for that. And it ended up in having mortality events and the decline in coral recruitment. And I'm going to show you, I'll try to show you this, I'll try to explain this. This is satellite data for temperature for our region from the period of the 1982 to 2013. And there was a significant increase in the temperature, but at the same time there was a significant decline in the now index. So when you look at the combination of positive or negative now index, which is this part of the graph, and also temperature anomaly, which this would be the 0 here, and this will be below and above that 0, and that 0 is based on the mid-monthly maximum of 28.5 centigrade for our region. If you have a combination of positive now and negative anomaly, which will be this condition number 1, you basically have no stress for the coral, okay? No bleaching, no major mortality, or anything like negative for the reef. Even if you have a combination of a negative now index and still a negative temperature anomaly, which is condition number 2, you still have no stress. But once you get to an increase in sea surface temperature, a positive anomaly, even under positive now, you can have some minor bleaching and some level of stress, which will be this number 3 stage. And the 4th stage is a negative now in combination with a positive temperature anomaly, and there you go. That's when the